Grenton Academy Part 2 – Preparing the installation for the smart home system. Good morning, my name is Marek Pollitt and I invite you to the second training video, from which you will learn how to properly prepare the electrical installation for the needs of the smart home system. In the previous part, you've already learned what devices can be connected to the system and what functions we can use to realize it. Of course, in order for these functionalities to be possible, we must prepare the electrical installation properly. We also told you that modern topology, called star topology, is the best way to conduct cabling for the needs of the smart home system. Why is it worth installing an electrical installation in a star topology at home? First of all, we bring all cables from all devices that we control to one place, where our electrical switchboard will be mounted. This way of conducting the installation will be the most secure because all connections will be in one place and the most flexible at the same time. And if we want to make any changes in the future, we can directly connect all wires in the switchboard itself. The electrical switchboard that will be used for this type of installation will usually be larger than in a traditional installation, which in turn will facilitate service, maintenance and modernization works in the future. This type of switchgear will be much more ready for future devices, future solutions that can show up at home, than in the case of traditional electrical installations. We should remember that we usually build a house for life. So it's worth making sure that such an element as electrical installations is adapted to what may happen in the future. Electrical installation in a star topology. What it really means. If we look at a very simplified view of how a traditional electrical installation is built, which we can see in this diagram, we will see that the cable is led from the switchboard directly to the switch, and then from this switch it is led directly to the lamp. In the case of installations in star topology, we lead the cable as before to the switch, but the cable is led directly to the lamp from the switchboard. The diagram presents how the installation in a star topology is carried out. In the middle, we see here an electrical switchboard in which the fuses and our control modules are installed as standard, and a series of receivers from which the cable is led directly to the control switchboard. That is, if we want our system to control lighting, electrical sockets, garage gates or blinds. The cable must be led directly from that device to the electrical switchboard. What kind of wire will it be? Here we really have to choose the cables depending on which device will be controlled and how. And let's examine each case in turn. Let's start with lighting. In the case of lighting, a typically electric cable for lamps, e.g. YDY 3x1.5 wire is used, which in this case will be pulled directly from the lamp to the switchboard. It can be one lamp or it can be a group of lamps. Please remember that if we want each lamp to be switched separately, then the cable has to be led separately from each lamp. If there are, for example, 3 lamps in the living room and we want to switch on simultaneously all 3 at once, then it's enough to connect one cable to the living room with the switchboard and then connect all these lamps with one cable. In the case of electrical sockets, exactly the same principle is used, except that it is customary here to use 3x2.5 YDY wire in a thicker cross section due to the higher load that can be connected to the socket. And also, in the case of lighting, if we want to be able to control each of the sockets individually, then we need to route the cable directly from that socket to the electrical switchboard. If we would like to control a group of sockets, then all we have to do is lead the one wire to the first socket and connect the rest of the sockets with each other. The entrance gate and garage gate are a little different. Most of the devices that I have met so far were controlled by so-called no contact, All you need to do is give a short impulse to a specific input to open, stop or close the gate. In most cases these are low voltage signals. We just recognize a short circuit, so in this case there is no need to lead a purely thick electric cable. Just a low voltage cable is enough. It is good practice to use a twisted pair cable in this case, which has more pairs and in the future will allow to use free pairs for other receivers that we will want to control. As in the case of lighting and sockets, here also a separate cable is led to each element. i.e., if a garage door is to be connected to the system, then one cable is led, for example UTP cable, directly from the switchboard to the place where the gate drive will be mounted. Similarly, in the case of an entrance gate, a cable, for example UTP cable is led in the case of a garage gate, it has to be RBE. Remembered of course that the gate is outside and it should be a gel-filled cable used for installation in the ground, and that cable is also led directly from the switchboard to the place in which the controller or gate drive will be mounted. For blinds, an electric wire is also needed, or maybe not. In the case of roller blinds, we have two options here. There are two types of engines on the market, 230 volt AC motors and 12 or 24 DC motors. If at the construction stage we do not know yet what motor blinds will be equipped with, it's best to arrange a typically electrical cable in this case. Does it have to be a wire with a cross section of 1.5 as for lighting? Not necessarily. Most drives have a power of 150 to 200 watts, which means we could easily lay a 0.75mm square wire. For safety reasons, here I leave the decision up to you. If you are able to determine what the power of your drive will be, we can choose the cable very precisely. If not, I think it's good practice to use the cable excessively, i.e. we use a 1.5mm square wire. How many wires? For blinds we need at least 4 wires for each window, because we have here a little more signals for each drive. To each window we need to connect the neutral wire, protective conductor, i.e. we already have 2 wires in the cable, and additionally a wire for controlling the upward direction and a wire for controlling the downward direction. i.e. each cable that we will put into the blind will be a 4 wires cable, for example a YDY 4x1.5. We arrange it in exactly the same way as in the case of sockets or lighting, i.e. a cable is led directly from the switchboard to the window we want to control or to a group of windows. If we wanted 2 or 3 blinds to be switched on simultaneously, then we can connect them to one circuit. However, it is good practice to separate the circuits that are to be controlled. It may seem today that we want to control certain windows in groups, but please remember that if the installation is prepared in such a way that in the future it will not be possible to separate these windows. It will not be possible to control those windows separately in the future. However, at the moment we are talking about connecting the drive itself. If we are talking about blinds, and I will skip a little here, we usually install a switch next to the blinds. Of course, in the case of the smart home Grenton system, this switch may be in a completely different place than the roller blind, because we can control the roller blind from any switch, or skip the switches and control using the application. But if we wanted the installation to look like any traditional electric installation, then in the vicinity or near the window, a switch to control the blind should be installed. How to wire that switch? Exactly the same as the other elements were wired, i.e. a wire is led from the switch directly to the switchboard. It's not acceptable to connect a switch to the roller shutter in parallel and control the roller blind directly to the controller. There is a certain risk here that if the system wanted to open the window and somebody approaches, then with the switch they would be able to apply voltage to the opposite direction, which may result in burning the engine. So here again, in the case of blinds, the blind is connected with a YDY 4x1.5 cable, for example directly to the switchboard, and the switch is connected via a cable directly to the switchboard. They are not connected directly to the engine. What kind of wire will it be used in the case of switches? It can also be an electric wire, for example a YDY 3x1.5, but instead of using a wire with a large number of miles, we can replace it with a UTP wire. The use of UTP, which is a typical computer cable, also allows us to use it in the future for other purposes. We can, for example, connect a temperature sensor in a free pair in such a place, or in the future connect even a control panel, because the UTP cable can also be used as an installation of the Grenton system. In the case of an alarm system that we would like to connect to our system, there are two options here. If we would like our alarm system to be fully integrated, remember that today we have full integration with the Sattel alarm system from the Integra series and with the Jablotron alarm system. Then between the place where the alarm control panel is installed and the place where there will be located control modules, the UTP transmission computer cable must be connected. If we wanted or just needed a simplified integration with such an alarm system, we would like to alarm, for example, through the system's inputs, this UTP cable really should be enough. For safety, I recommend laying double the number of wires. It may turn out that you will want to add more sensors in the future, or connect more devices, or have feedback from the alarm system. So here, between the switchgear and the place where the alarm system will be installed, where the alarm control panel will be installed, i.e. the control panel, we are talking about the electronics plate and not the keyboard at the door. We lead the UTP computer cable to that place, preferably in double length. Let's come back to the switches now. Of course, lighting, blinds, or other devices in the system can be controlled using traditional, ordinary lighting switches. It can be any switch that we choose from the market, any switch from the offer of any other manufacturer. Of course, one that controls by shorting the circuit. Now, what wire should be inserted into such a switch? Maybe we'll start with in what way. Here, as in the case of lighting or sockets, a star topology is applied. The cable is led directly from the switch to the control modules, which are located in the switchboard. And now, what wire could it be? Exactly as in the case of roller blinds, a typically electric cable YDY 3ONY can be applied. We can use low voltage cable. It can be a YTDY door phone or a YTKSY phone cable, but the best practice is to use a typical computer transmission cable here, a UTP cable. The use of our UTP cable gives us some advantage. When connecting the switch keys for a single switch, two wires are used. There is one wire to be connected to the ground connection, and one to be connected to a specific input. There will be 3 wires for 2 keys, one to ground and 2 to the first and second input. A free pair of such a cable can always be used to connect temperature sensors or additional devices in the future. When UTP is used, there is another big advantage. If today a regular switch in a given room is installed, and in the future we want to install a touch panel in that room, then all we have to do is to dismantle the switch and on the UTP cable, which is already there, we connect the system bus, and we can connect touch panel or smart panel in that room too. The issue of sensors, i.e. contactors, motion sensors, or any other detectors that return a value in the form of 0 to 1, have a relay or short to ground. The cable is led directly from the switchboard to each of the sensors separately. What kind of wire will it be? Some manufacturers recommend not using twisted wires on the sensor side, so you should be careful here to verify and check. However, most sensors that are available on the market can also be connected to a typical computer wire UTP. So if we wanted a motion sensor to be connected to our system, the one we use as standard in alarm systems, it is enough to lead the UTP cable directly to the switchboard from such a sensor. A separate cable from each sensor is led directly to the switchboard. A smoke detector, monoxide detector, or contrast sensor will be treated in exactly the same way. A cable is led directly to the switchboard from each of these sensors. When connecting switches with an analog output, i.e. those from which we want to know the exact value precisely, in the case of a motion sensor or a sensor to open a door, we get information in the form of 0 or 1. i.e. when a threat is detected, a logical 1, or for example logical 0 will appear. And if this threat is not present, the opposite state will result. If we wanted to connect a sensor to the system that would return a specific value, for example a carbon monoxide sensor, a temperature sensor, or a humidity sensor, then this kind of sensor is connected to the analog inputs in the system and to them. And here, attention, we have to check with documentation. Always a twisted pair will be the optimal solution. Sometimes it must be a straight, typically control cable with a larger cross section. Certainly a twisted cable, UTP, will be the most universal here. If there are any unusual sensors that we do not know yet that might appear, it's best to use the redundancy of the cables. For example, bring the UTP cable and in parallel some control cable. Let's stop here for a moment as we are at the wiring stage. We discussed what cable and how it should be led to each of these elements, but I think that it's also very important where and what sensors can be mounted. If we want our system to control heating, there will be a temperature sensor in each zone, in each room where we want to control the temperature. So it's worth considering here when distributing the system to bring the Grenton bus into this kind of room. For example, to connect touch panels or a smart panel. Or if you don't plan any of these panels to have a room like this, then it's worth bringing the UTP cable there so that it's possible to install a temperature sensor in the future. It's definitely worth bringing outside, and not just in one place but in 2 or 3. Spare UTP wires, which can be used primarily to connect the outside temperature, to connect a rain sensor, if any, wind sensor or sun sensor, it's worthwhile in the case of conducting electrical installation to apply some excess, prepare more cables and lead more of them, taking into account that someday some such sensors might appear, even if we don't install them at the early stage. In the future, we will always be able to come back to that. Let's move to the Grenton bus now. The cables we just talked about were the cables that are led directly between the receivers to be controlled, or sensors, devices that will be plugged into the control modules mounted in the switchboard. If we would like to connect control panels or recessed controlling modules to the system, the connections are always done via a bus cable. And now, what does such a bus look like, and what are the rules that should be followed? The structure of the system is as follows. The CLU module, which we see here in the diagram, is able to support up to 48 I/O modules. The CLU module is the controller for its bus. We will connect all control modules to the CLU module via the local TPS bus. This CLU module supports up to 48 wall input modules. So if we wanted the system to support a larger number of modules, we add another CLU module to the system, to which we can connect another 48 input-output modules. We connect CLU modules using the Ethernet layer. We can connect them directly with each other. Each of the CLU modules has a 2-port switch, or using the existing network infrastructure. To put it simply, we can connect from the CLU the switch, the router, which are located on the side, and as long as all the CLU modules are seen in one network, they will constitute one whole large system. But let's focus on the bus between the CLU and the control modules. In the diagram below, you can see what a properly made Kento system bus looks like. The beginnings of the bus is the CLU module. The CLU module has 2 bus connectors, the left one and the right one, which means that from each CLU module we can run 2 bus branches, just like in this diagram. All modules that are assembled in the switchboard are connected with each other by main straps, but you do not have to order these straps separately. They will be attached to each module to be assembled in the switchboard. When preparing the bus for the Grenton system, we have to follow a few simple rules. First of all, the maximum length of the bus, as I mentioned earlier, can be no longer than 300 meters for one CLU. Another issue, the bus cannot be used from the plug. The star topology is not allowed in this case. And the next issue, we cannot close the bus loop. The CLU module is the beginning of the bus and always has a termination applied at its ends. The ends are never connected with each other. How do we make the bus in practice? In the case of modules that are mounted in the switchboard, we already know that all of them are connected together with a main strap. However, in the case of modules that are outside the electrical switchboard, those that are to be connected by a main cable, we use a Grenton belt, a special adaptation module that allows us to connect the cables to the bus in order to connect such a cable directly to the module. On the one hand, we have a main connector which will be connected to the last module, and next to the connector there is a cable connection, typical for connecting wires. And now we leave the module with a cable and go straight to the first flush mounted module. All flush mounted modules are fitted with bolted or push-in fittings, so there is no need for any additional connectors or adapters. The main cable will be connected directly to the control modules or touch panels. We lead the cable to the first panel, connect the bus out of it, and go out to the next and the subsequent, all the way up to the last one. We connect the terminator, i.e. the terminating resistor on the last module. What if the bus lines on the site were installed in the star topology? As we already know from the previous slide, in the case of the Grenton TF bus, the use of tapping is not allowed. We cannot connect such a star topology directly. If a bus like this was made with a Grenton smart cable, we were able to deal with this situation. We have 2 communication pairs for transmission in this cable. In this kind of situation, we use one of the pairs as the main pair, which goes to a given smart panel or control panel, and do the so-called return with the other pair. Then the return is connected with the next pair to the next module, and again we return with the next pair as a return until the last module. Please remember that the return should not be fastened on the return. A terminating resistor is mounted directly there, and in such an installation the cable has been laid out in a star topology, while the transmission still has a serial structure. Distances is what we need to remember about. For a bus connected in series, this distances will be the direct cable length. In this case, the bus length will be the cable length times 2. So if we laid a 25 meter cable to the first panel, the total length of the bus will be 50 meters. In the Grenton system, we use one more type of bus. This is the one wire bus that we use to connect temperature sensors in the DS18B20. Each analog in-out module has a controller of such a bus, which allows us to connect 2 branches of this bus and to support up to 16 sensors. As for the cable that we use to build this bus, it can be a typical computer cable, UTP, and Grenton Smart Cable of GF bus cable. How do we connect such sensors? We have to follow a few rules here. First of all, the bus should be a serial one. The maximum length of one bus thread should be no longer than 50 meters. Another very important piece of information: when connecting sensors, we use the so-called parasitic voltage. We do not connect the voltage to the sensor's feed, but we supply it directly from the data bus. This means we need to perform a small procedure on the sensor itself, namely the 2 extreme legs. Those that are responsible for the power supply will be marked as VDD and GND. We connect them together, bridge, and connect directly to the GND connector with a 1-wire bus. And the data bus, marked as data or DQ, connect directly to the 1W bus in the system. It's best to make the connection as close to the sensor as possible. See now how the system architecture can be built. There is here a typical system. The CLU module was installed in the switchboard. Some control modules were also installed in the switchboard. In addition, flush mounted modules and control panels. What is the hybridity of this system? If everything is connected as here in this selection, the CLU will manage the modules that are connected to it and will carry out remote communication and perform advanced logical functions. If for some reason the CLU module was disconnected, the bus would break and it would be damaged. Then the modules that are further connected to the bus will be able to exchange information with each other. So, to put it simply, if the CLU module stops working, then the switch will turn on the lamp or several lamps. It is possible to configure it this way, and the temperature sensor will still control the heating, just like a regular thermostat. Another element: there is a wireless module here. If the Grenton system is installed here, it will not be only either wired or wireless. These 2 types of structure can be freely combined. So if we lead a bus and an installation in such a way as to make a wireless system, but it happens that we forget to lead cable to one place, we can always mount the wireless system in this kind of place without losing the functionality of the entire system. There is one more element that I would like to draw your attention to. This is the internet access for our system, through which the system will be controlled from the mobile application. It is worth remembering that from the place where the CLU or electrical switchboard will be installed, to lead the UTP or FTP computer cable to the place where the router switch or access point will be mounted, from which we will use the internet, as these devices are not always installed in the switchboard, and this is worth remembering for the future. Another example of a structure is a system with many CLUs. Look here, where the CLU modules can be combined in several ways. We can connect them directly to each other or using existing network infrastructure. What's very important here is that as long as all these CLU modules are connected into one local network, we constantly talk about one large system. Here we have another example of a Grenton installation. This is a mixed installation. You can see here how you can adapt the system architecture to the needs of the building. Suppose we have a large building. This is a large residence. Let's say there is a recreational part located in the basement, for example a swimming pool, a sauna or a relaxation zone, and a residential part on the first and second floor. Now we can see how we can adapt the system structure to such a facility. In this part, which is located in the basement, there is a switchboard installed in which there is a CLU and control modules that are responsible for controlling this PAL part. In this case, the cables from the lamps, sockets, switches, which are located in the basement, will be entered directly into this switchboard. On the first floor there is a switchboard in which there are also CLUs installed, and to this switchboard are also brought in cables from all devices that were installed on the first floor. On the second floor there is another switchboard, but please note that there are no CLUs here anymore. It turned out that for the first CLU we did not exceed 48 modules, and the bus length allows for the next devices to be connected using the bus structure. So you only need to lead the bus cable to that switchboard and connect all of them to the bus from the second CLU module. So here you can see how we can adapt the system structure to the conditions prevailing at the site. Thank you very much for your attention, and I invite you to the next films, from which you'll learn, among other things, how to correctly select modules, to expect functionality, and also how to configure the system. Goodbye.